Okay, class, today we are going to start chemical reactions. This is an interesting topic because it really is the most important thing, I believe, to chemistry because chemical reactions are so important. So, chemical reactions are a process by which one or more substances are changed into one or more substances. There are many chemical reactions that take place day to day in your body, throughout the universe. You would not be alive, and the universe would not be a thing without chemical reactions. You have seen a chemical reaction before, and I'm going to put an example of the chemical equations that you've seen. So the chemical equations that we're going to use in chemical reactions are formulas. And you have seen a certain one. So I'm going to give you an example of a chemical reaction, and it'll probably come back to your mind once I start writing the full thing. So this is the chemical reaction for photosynthesis. You probably learned it last year, and you learned that light plus carbon dioxide plus water yields glucose and oxygen. So this is what an example of a chemical reaction that I probably won't give you since you've seen it so much, but we're going to learn the parts of a chemical reaction first. We'll learn how to balance a chemical reaction, so with these numbers in front, and then we will also learn different types. So there are 5 different types we will learn, and how you can predict products when given one side of the reaction. So we're first going to go into detail on just what a chemical reaction is. Like I said, it's a process where you start with one or more substance and they are changed into another substance or one or more substance. So you can tell when you have a chemical reaction because light or heat will be produced. There will be a production of a gas, or there will be a precipitate, which is really just another word for a solid that forms. So the things that we've talked about in the last class, phase changes, those are really physical changes. That is not an example of an example of a chemical reaction because new things aren't forming. It's still really the same thing. Like I was giving the example a lot that ice was turning into water. That's still H2O. It's not changing. These chemical reactions will form new products, or a gas, a solid, or heat and light will be given off, so you know that there is a chemical reaction taking place. In these chemical reactions, when we complete them, we have to balance them. And I'm saying this kind of like you don't know what I'm talking about at first, but we have to make sure that each side has the same mass. So we learned this at the beginning of the year, law of conservation of mass, where matter is not created or destroyed in an ordinary chemical reaction. I made you guys do a lab with an open and closed system where you guys used a Ziploc bag and you masked it before and masked it after. And it was the same, like once the chemical reaction took place, it was the same mass because mass is not created or destroyed. So in chemical reactions, we have to make sure that everything is balanced out because no matter will be created or destroyed. And I'll show you what I mean by that. And so there are a couple things that you need to know for the basics of equations. And they are that each equation will be made up of reactants and products. Reactants will be on the left side of the equation, and then there will be an arrow, and products will be on the right side. So reactants are on the left, and they're really the starting material. Products will be on the right side, and they're what you are left with. So it is the final material. So, an example of a reaction that is necessary for life, if we didn't have this chemical reaction, we'd have some pretty rough times. This is the reaction of water. So, the reactants of this chemical reaction would be on the left side. It would be this H2 and this O2. The products would then just be this water. So, I'm going to break down what this equation means, what these numbers mean, and how this is balanced, coefficients are used, and even what state symbols would be used in this exact reaction of water. So I just rewrote this equation at the top so I can write some pictures below. In one chapter this year, we talked about molecules and certain elements that are diatomic, which means that they have a 2 when in their elemental form. So molecular hydrogen is one of those ones I gave you that term H. Bro Finkel. It is one of those diatomics. So when you put hydrogen by itself, it will appear as 2 hydrogens. In this reaction, it is saying we have 2 of those, though. Oxygen, we have only 1 of them. There is no number there, so that means that there are 1. And then we have 2 waters. So, this is basically what that equation is telling us. So that is a balanced equation. If you take a look at the reactants of the equation, I'm going to do some jotting down. We have 4 total hydrogens. We have 2 oxygens. So that's for the reactants. If you look at the products, we have 1, 2, 3, 4 hydrogens, 1, 2 oxygens. So this has the same number of atoms on the left and on the right side of the equation. And those atoms take up mass. Just how I made you guys look at the molar mass on periodic tables. So this is a balanced equation because on the left and the right side, matter is not created or destroyed. We have the same exact numbers of molecules of hydrogen and molecules of oxygen. So, a balanced equation shows the relative number of atoms of each of the elements involved. And we don't really have to worry about mole ratio, so we'll figure that, or we'll do that really if we make it to the next chapter in this class. Coefficients are numbers placed in front of a compound to balance the equation and multiplies everything in the formula. So that's these numbers that I did, or I underlined in red right here. Those are examples of coefficients. Those are used to balance the equation to make sure all of the atoms equal the same amount on the left side and the right side. And this is to satisfy the law of conservation of mass. State symbols is another thing that will take this to the next step. So I'm just going to rewrite this formula, or these formulas at the bottom, and I will draw in their state symbols. State symbols indicate the state of each of the substance, and states is really what type of matter you have. And that's why we went over phase changes the day before, because you will have to indicate if something is a solid, a liquid, a gas, or if something's aqueous, which we'll go over. You don't really know what aqueous means, but in this case, you can look on the periodic table to see where hydrogen is and see if it's a solid, liquid, or a gas. You will place that in parentheses right next to each of the element or the compound that is in the reaction. So I'm writing that L as a liquid, and we'll go over which, in the next part of the notes, I go over what they mean and how you can determine state symbols. So don't worry about that just yet, but I'm going to So for these state symbols, I will discuss how to figure them out, and I would keep these notes together because this will be helpful for the rest of the chapter. I'm going to split up these notes like I have right now in chunks so it's easier for you guys to take them. And in this part of the notes, I drew these I drew those molecules. You don't have to draw molecules for this chapter. I know you guys didn't like that to begin with, but I just wanted to show you visually how two of these reactants would come together and become these products. And I wanted you to see how the left side and the right side have the same amount of these elements. So hydrogens equal the right side and the left side. The oxygens are equal. They have the same number. And one thing I forgot to mention, if there is no coefficient in front of something like right here, that means that there is a 1 there. So if there's nothing written, just like how we would write a certain element like argon, if there wasn't a number at the bottom, we would think that there would be a 1. So it's kind of similar to that. Okay, so the other things you will need to know for chemical reactions is there are certain symbols in chemical reactions. So when we write a reaction, it is our reactants, an arrow, which means yields or produces the products. So that arrow means yields. If you see a reaction with double arrows, that means you can reverse the reaction. So you can then turn the products into the reactants further. So you can go back and forth between the products and the reactants. Some more symbols that I briefly went over were the state symbols. So whatever state the substance is in, either a solid, liquid, aqueous, or gas. Aqueous just means that it is soluble in water. And soluble really means that it can dissolve. So you will be able to tell whether something is a solid, liquid, aqueous, or a gas in a reaction. I'm going to teach you how to figure out the state of something. Whenever you see it in a reaction, you will need to figure out the states of compounds or elements in a reaction. So there are some things that can be added, some symbols that can be added on top of the arrow or the yield arrow, like a triangle, a number, an ATM, a temperature, and then the term MnO2. These are all different conditions you can add to a reaction to make the reaction either happen quicker or to speed up the rate of the reaction. So these things are used to speed up the reaction. And they will always be listed. So that triangle means that heat is applied, like with a Bunsen burner or something. Pressure can be added. A specific temperature can be listed, or a catalyst. A catalyst is just something that will speed up the reaction. Our last really introduction, or the last bit of the introduction, will be determining state symbols. So you will be given either an element, a compound, or a molecule, and you will have to figure out if it is a solid, liquid, gas, or if it's aqueous. So for plain old elements, you will have to look at a periodic table, which I will post on Classroom, and see what color the element's in. If it is in black, it will be a solid. If it's in red, it will be a gas. And if it's in blue, it will be a liquid. And we did this throughout the year already because I made you look at the periodic table to see if something was a solid, liquid, or a gas. And you would always see that the noble gases were in red, the solids, all the metals were in black, and then the two liquids, bromine and mercury, were in blue. So the other types of compounds you will need to be able to determine the state symbols of are ionic compounds, and you will have to check a table called solubility table, and I will post this on Classroom also. And it has some terms in, I'm going to erase this real quick. It has some terms in this box that you will need to be able to use with the compounds. So when it says something is nearly soluble, or I, on this table, that means it will be a solid. If a compound says slightly soluble, which is SS on this table, it will be a solid. So that means that the solid you are putting and dissolving into water does not dissolve. It's insoluble. So these things don't dissolve. And they will stay a solid. Soluble means that they do dissolve, so they will be aqueous. And in this table, soluble is just referenced as S. So for an example, if you look at the example I wrote, aluminum iodide, to figure out whether something is a solid or aqueous from this solubility table, you will find aluminum and you will find iodide. You will meet the two together and look to see what symbol is in aluminum iodide. It says it is S, which means soluble. And when something is soluble, its state symbol will be aqueous. And that is how you figure out for ionic compounds whether it is a solid or if it is aqueous. And we will do more examples, and you can answer or ask questions if you don't understand what and how to use this table. For metal oxides, so any metal that's on the left side of the periodic table and oxygen will be a solid. Any nonmetal, so right side, will be a gas. Water is always going to be a liquid, except for in a combustion reaction, but I will give you guys a hint that it is not a liquid in that case. And then these are some of the common gases you will need to write down and remember. So I would always have that written down in all of these notes in your note packet, because you will have to figure out if something is a solid, liquid, gas, or aqueous. And this stuff really will help you out throughout the whole chapter. So right now we're going to work on a worksheet, and